All right, so here we have an example of a line graph. I'm using a graph from mathaids.com. And if you notice, the first bit of information they're going to give you is along the x-axis. Remember, our x-axis is going this way. The air temperature on the 29th. So it's kind of like in the door to 29. And we go in the door to 29, and then they want to know the air temperature. Now notice, in reading a line graph, it's super important that you pay attention to the label on the x-axis and the label on the y-axis. So here, what's the temperature on the 29th? So we go to the 29th, and then we've got to go up to where it intersects and then shoot it across to read our y-axis, which is 12. 12 degrees in Celsius is the air temperature on April 29th. What is the air temperature on the 1st? Well, we've got to find the first on our x graph and shoot up, and it goes over to the 14 degrees. Now, what's really cool about a line graph, again, it shows change over time, is that you can actually take a look at the average. So in between 1 and 8 is probably about 5, 4.5. And if it's going to be right here, and if we were to shoot up, we can make an estimate that our air temperature on about the 4th or 5th day of April is about 15 degrees Celsius. Now, looking at the data on the bottom, did the temperature increase or decrease between the 15th and 22nd? So now they give you a range. The range is 15 to 22nd. Now you have to interpret the line graph. Did it go up or did it go down? Well, it went up. Therefore, the temperature then increased. It actually went from 4 to 10. So that means our range for this is 6. That's the distance, the temperature difference between the 10th, the 15th, and the 22nd. That's pretty much line graphs. Pretty easy. Interpret the information. It'll tell you something along either the x or the y-axis. Find where it is, shoot it up, and then shoot it across. See you tomorrow.